So we'll be talking about solutions today. So when I say we're talking about solutions, I don't mean that I'm going to be answering a whole bunch of problems for you. I mean that solutions is a special category of chemical substances. So I'll give you a couple classic, really easy, really familiar examples of solutions for you to start. First one, salt water, right? Let's see, we also have Kool-Aid. We also have human blood, right? So these are all examples of solutions. So what to think of when you think of a solution is the thing that you may or may not realize is consistent when you cross these three examples, is that a solution has one substance, just abbreviate substance here, dissolved has two in another. That's what a solution is. Oh, another great example of solution, but this one's not as familiar to you, air. Right, so anytime you have one substance, one chemical species that is dissolved into another, you have a solution. The most typical versions of solutions that anybody sees or anybody works with are water-based solutions. So salt water, Kool-Aid, things like that are water-based solutions. Solutions that are dependent on water, where they are dissolved, if something is dissolved in water, is known in the chemistry world as aqueous. So let's just get some basic terms out here. This is very much an intro to solutions. So a solution is one thing dissolved into another. Solutions, the two parts of a solution we have special terms for. We have the solute and we have the solvent. So the solute is very simply the substance that is dissolved, and the solvent is, let's say the solvent is what dissolves, with an S at the end, the solute. So think of it that way. Whatever stuff gets dissolved in your solution, that's the solute. Whatever is dissolving, whatever is taking the action of breaking apart that substance, that solute, is called the solvent. So let's think about salt water, right? In salt water down at the beach, right? Everybody's tasted salt water. You can't see the salt most of the time when you're looking at it, but you can taste it, you know it's there. That's because it's a solution. A solution is a really, really good mixture that's hard to separate. So in salt water, right, the solute is NaCl, table salt, and the solvent is water. So our solutions are very simply made up out of two parts, the solute and the solvent. There's another kind of general thing to get into with solutions while we're here today, and that is the idea of concentration. Now, concentration can take on a lot of different forms. We're going to talk about something in a future video about molarity, which we abbreviate with a big capital M. Let's do that better. That's a little hard to see. Capital M. Oops. But another form of concentration is density, which we've already talked about. And another form is even percentages. Right? These are all forms of concentration. So concentration is and these three things are very much a representation of how much solute per your solution. We'll abbreviate solution, SOLN. Right, so that's something to keep in mind. Molarity is the chemistry exclusive concept that we'll talk about a little bit more. But density, you've heard of that before, right? Grams per milliliter or grams per centimeter cubed. It's how much mass per the volume of the whole object. And percent is actually kind of a concentration too. Think about a test. If you take a test and you get 90% right, that's a 9, not a 10. 90% right. That means that you had a concentration of correct answers of 90% or 9 out of 10, right? It's showing you how much you earned out of the whole piece. That's basically what concentration is in every situation. It's looking at how much of this giant substance, this giant piece, is this smaller subset that we're looking at. Whether it's points correct. For molarity, we'll end up seeing that it's moles. That's not too strange of a concept. Molarity and moles, you can kind of hear the similarities there. For density, it's how much mass in an area, right? Concentration is really just a special kind of ratio. So that's something else we'll be seeing here.